Hi, I'm Parisa, and in this video we want to talk about Kubernetes cluster management via Azure Arc. What we want to do in this video is to provision an Azure Kubernetes cluster and connect it to an Azure Arc service. If you want to have multi-cloud solution and you want to have server machines and databases and Kubernetes instances, cluster instances on different environment on your on-premises, Arc is a solution for you. I will provide you in this video the way that you can connect your AKS to Azure Arc. First, we should know some theories. The Kubernetes cluster can be provisioned on AWS, on GCP, on Azure, or on premises. You can connect all of them to the Azure Arc. Some users or some partners, some customers of Microsoft use Azure Stack. Somehow kind of Azure Cloud, but on-prem. You can connect the Kubernetes of Azure Stack to Arc as well. So, two extensions you have to install on your machine where you are developing or using for your CI/CD build agent. You need to have Azure CLI, AZ CLI. You need to have Helm command line. You need to have kubectl command line. You need to have AZ extension for connected Kubernetes. I will show you how you can install it. And you would need the extension, Kubernetes extension command line. They are the extensions of AZ CLI, and I will show you how you can install it first on your machine that you are using for developing this topic or this stuff. Then you should take care to install the extensions on the build agent where the automated CI/CD pipeline will be executed. I'll show you fast how you can install the extensions. I assume that you have already installed the AZ CLI and you have to see the current version. I can provide the link of the page where you can see the prerequisites, which version of the CLI command, AZ CLI, should have been installed on your machine to be able to install these two extensions, because I think from version 2.4 or something like this and higher, you can install these two extensions. Then we can see which extensions do we have for installing. If you don't know extension, if you don't know what parameters you have to provide in this command line, you can easily write AZ extension. The available example will be provided here for you. For example, I want to see the list available extensions, and then I can say -o to provide the output format, and then I say table. The output would be in the table format. One of the extensions that I need is connected Kubernetes. In C, then you have to see connected Kubernetes, and then is Kubernetes extension. Kubernetes in K, Kubernetes extension. This one is to connect Kubernetes cluster to Azure Arc, and this extension is for installing operators or extension on Kubernetes itself. Then I go ahead, then I go ahead with this command. az extension add --name and connected Kubernetes. Of course, we see that I have installed it because I installed it already to be able to provide this video. And for the second command, you can do the same. You can copy and paste the command. I would provide a link in my video description to this PowerPoint slide to be able to install these two commands that we would need. We have seen many extensions in previous slide which are available for AZ CLI. But these extensions are CLI extensions. Then we have the extensions that we can install on Kubernetes. For example, monitoring extension, which will be installed on Kubernetes, or Azure Policy and the others. I will provide in this video the monitoring for container extension installation, and I will provide the code. The extensions that we talked in the previous slide, in this slide, are some of them cluster based and some of them are namespace based. The Kubernetes experts know about it. Kubernetes contains, Kubernetes is a cluster. Cluster contains one to many namespaces based on the scenario and the strategy that you define for managing the Kubernetes resources. If you deploy an extension or operator to Kubernetes cluster scope, then only, as I mentioned here, only one instance of this extension will be installed for the whole cluster, and all the namespaces can use it. And only once the pods, operator, and CRDs are created. But if you install an extension in a namespace based, then you would have pods based on for each namespace. It is somehow a kind of resource consuming. I would not recommend it as long as there is really a reason to install the extension for a specific namespace. Then another important point is when we are installing an extension, for example, monitoring extension on a cluster, then we can specify the name of namespace or release namespace for this extension that we are installing on Kubernetes. Another point that we should consider is Arc agent. When we are connecting a Kubernetes cluster instance to Azure Arc, an agent will be installed on Kubernetes cluster, and we should take care about it to keep it always up to date. How we can upgrade this agent? You have two possibilities. Either you want to have operational overhead and you do the upgrade manually, or you won't have operational overhead, which I would recommend you, then is using auto update. Before we go forward, I want to explain a little more to give you a better overview. We assume that we have a Kubernetes cluster instance anywhere, on premises, on Azure, AWS, GCP, Azure Stack, somewhere. It doesn't matter. We want to connect this cluster to Azure Arc. we use command line, AZCLI command, to connect this cluster instance to Azure Arc. When I create this connection, a projected instance will be created for you, which is only metadata, the Kubernetes config information data, which allow or make it possible for Azure Arc Service to connect to the cluster and install extensions. In this video, we create the AKS cluster. We use AZCLI. We connect the cluster to Azure Arc Service. A projected instance will be created. I will show all of them to you in next slides and in Azure Portal. And then we go in this way to install monitoring extension. The monitoring extension will be used via Azure Arc. Azure Arc send the command to the projected instance, the metadata, or maybe it is a wrong word to say send command to projected instance. It is only metadata, only kubeconfig, we can say. It is only the information of your Kubernetes endpoint, and then send the installation command to the AKS cluster in this case, and the cluster will be extension will be installed. In the first step, that I'm connecting Kubernetes cluster to Azure Arc, and Azure Arc agent will be installed on the cluster as well. I will show you the namespace of the Arc on your cluster, and you should keep this agent always upgrade and up to date. Okay, we continue with the slides. In the video that I will show you in the implementation, the whole implementation is in Terraform. Unfortunately, for time being, there is no Terraform resource for Azure Arc configuration or Azure Arc connection. Therefore, I will jump from Terraform to CLI to connect the Kubernetes Azure Kubernetes cluster to Azure Arc, or of course you can use resource AZ API resource. It is the resource of Terraform. One point that you have to consider here is that resource AZ API resource is only creation command, not the deletion command. Therefore, when you use it to provision a resource, then the resource will be created or provisioned. But if you remove this resource from your Terraform file, usually when you remove a resource from TF file, the resource will be deprovisioned. But in this case, the resource would not get provisioned because it is only creation command. It is the difference between, for example, usual Terraform resource and this AZ API resource. The deletion or deprovisioning cannot happen here. You should develop a workaround to deprovision a resource. I think I have explained enough theory. Let's go to the actual implementation. First of all, based on the steps that I have demonstrated here, we need a Kubernetes cluster, and then we connect the Kubernetes cluster to Azure Arc. In the cluster implementation or AKS implementation is in this main file. Maybe you have seen the same implementation in another videos. The repository is the same, only I extend the implementation in my repository based on the later videos that I provide. Cluster has been created in a resource group with an ACR. One thing that is important to consider for Kubernetes cluster on Azure, which you want to connect to Azure Arc, is that you see that I have managed identity implementation here as well, but you must ignore it right now. Why? Because right now only the AKS clusters or Azure Kubernetes cluster, which are created with system managed identity, are supported to be connected to Azure Arc. Therefore, you see in my implementation that I have removed the identity which I used for my cluster, and I have removed the client ID of the managed identity which I used for my kubelet identity. It means the whole Kubernetes cluster AKS will be created with system assigned identity. It is the first point that we should consider, unless you cannot connect the cluster to the Azure Arc. The rest is the usual implementation of the AKS. And then the role assignment, you can ignore it. It is only for the time that I'm using manage identity. And the rest, exactly, they are not important. Role assignment is not important as well, because when you are creating a Kubernetes cluster on Azure with system assigned identity, the role assignment will be done automatically. This one is not important, but pool is important. As you see, I have AKS pool here. It is my user node pool, and I have default node put in the implementation. It is system node pool, which the extensions will be installed on it, where the operators will be installed on it. Of course, you can configure the deployment to be installed on another node pool as well, but only I wanted to show you the difference. The rest information are not relevant for this video. Maybe only non-interactive call would be important because I'm using Service Principal for my command line to create a cluster. Therefore, when you are using Service Principal as your CI/CD user, then you have to use, let me show you non-interactive. You have to use kube logging convert config, unless you cannot log in or you cannot get credential of your Kubernetes cluster. You can get the credential, but you cannot call kubectl get node, because after you get a credential and call the kubectl get node, then you would see a prompt in your command line to sign in to the Azure portal, and it is not possible when you are in the CI/CD pipeline. In the CI/CD pipeline, everything should be non-interactive. Only as you see this implementation in my code, then you know why I used it in my videos. Okay, let's go ahead. I have used, of course, my terminal to deploy the AKS. And if I go to the Azure portal, in resource groups, because I know where I deployed the cluster has been deployed here. It is the cluster that I have provisioned with my Terraform code. And these two managed identities, they are a user assigned identity that I didn't use it. I didn't use it because I wanted to connect the cluster to Azure Arc to show you how it works. After that, as I mentioned, when we want to go to the next step, to connect Kubernetes cluster to Azure Arc. Actually, I implemented the connection here. For Azure Arc, for connection with Azure Arc, I have created a second resource group to keep the Azure Arc resources in a separated resource group. And then I jump from Terraform implementation to the Bash implementation, and exactly in Arc Connection Bash. In Arc Connection Bash, I pass the variable that I would need for my connection, and then I configure the kubeconfig here. Configure the kubeconfig here. It is very, very important if you want to have kube logging in your CLI or in your build agent, because this command will look at environment variable kubeconfig. Then I log in with my Service Principal. This registration must be finished. It is really important for our Azure Arc that these providers have been already registered in our subscription. And when I log in with my Service Principal to the tenant, then we know in which subscription I'm working, and these providers will be installed to this subscription. And then after registration, I will check if all of them are registered or not. And when the registration is finished, then I go ahead with get credential to get a kubeconfig based on resource group and cluster name. And the config file has been mentioned here as well because I have changed the kubeconfig file path. The get credential command must have been called before the kube login, because kube login look at kubeconfig environment variable to find the path to the kubeconfig, get the kubeconfig, and save the client ID and client secret credentials in the kubeconfig file to make it possible to communicate with Kubernetes cluster without interactive logging. And it is very important for CI/CD pipeline. As Azure Arc installation agent installation on Kubernetes cluster is based on Helm chart, therefore I clean the cache. And then, as I mentioned before, I check the extension for AZ CLI. Actually, it is the source code. It is the code that I have found in Microsoft documents. I check if the extension connected Kubernetes has been installed or not. If it has not been installed, then I install it. If it has been installed, then I update it. And then I go ahead to connect the Kubernetes name. It is the name of projected instance. It is the name of this metadata instance or projected instance. It is not a Kubernetes instance, actually, it is only metadata. And create a projected instance in resource group that I have created for Arc in this location. This location is only the location for keeping metadata. For example, if you are creating an AKS Kubernetes cluster on AWS, you can use, for example, Europe Central 1, which is in Frankfurt, and then you can use here as location, for example, Central West Germany, for example. Then you know that the metadata, only the metadata of the cluster that you have created on AWS somewhere in Frankfurt will be saved in West Central Germany, for example. It was only an example. And then I will show you how it looks like. Then I explained why I create a service account on Kubernetes and create a secret for it. Okay, I jumped to Azure portal. As I mentioned here already, this resource group is where I have provisioned my cluster. I have used the same name as a projected instance or metadata instance for Azure Arc, only that I know which metadata belongs to which cluster in my portal. If we look in resource group list, we see that we have for Arc resource group here, and you see the instance. The difference is a blue oval is appeared here. The difference is only that, and you see Kubernetes Azure Arc. It is only a metadata, not a cluster. Of course, if you go to Kubernetes cluster, you see the both, but one of them is the exact or actual Kubernetes service, and the other one is Azure Arc instance or Azure Arc Metadata instance. And you see in the name as well. They are under two different resource groups. I would go, of course I can click on it, but I want to show you from the beginning. You can go to Azure Arc or here looking for Arc and then go to Azure Arc. Then you can go to Kubernetes clusters and you would see the metadata instance here. When you click on it, then you see that connection is connected. It works. It is fine. Everything is okay. But when you go to namespaces or to the workload or service or ingress, you can see nothing. If you pay attention here, we should provide a service account bearer token. And it is the reason that I created a service account on my cluster, and created a secret for it in the previous step. Okay, then I jump back to my implementation here. You see that I have created a service account, Azure Arc UI user, because it is for Azure Arc UI, this UI I mean. And then I gave admin role on cluster level to this service account, and then created a secret, and then I get the token and keep the token in the txt file. It shouldn't be the reason. It shouldn't be the implementation for the production. Of course, you can use Azure Key Vault to keep the secret. But I wanted to show you very fast and quick how you can get the token for this part. The token has been saved or kept in token.txt. I go to token.txt, I copy and paste it here. Okay, let's copy the token and paste it here. Make the browser appear and then sign in. Great. You see that Azure Arc namespace has been installed in a cluster level, and agent is in this namespace. The other ones are the default namespaces. You can of course see the Azure Monitor. It is what I want to explain to you in some seconds. The good thing here in Azure Arc is maybe you have, let me go back. You can have Kubernetes cluster on GCP. It will be displayed as metadata instance here, or metadata object. You can have cluster on AWS. I will show you in a later video. You can have cluster on premises. You can have cluster in Azure Stack. You can see all of them here. It doesn't matter how many cluster you have. If you click on one of them, for example, on each of them, doesn't matter which one, you can go to extensions, and then without logging to Kubernetes, you can install the extensions from here. But actually, I don't want to install an extension from here, or it's better to say that I have installed it already, but not from UI, also from Terraform. I will go through the steps in some seconds. Great. Let's jump back to theory a little. As I mentioned here, after the AKS cluster is connected to the Azure Arc, Arc still doesn't have permission to see AKS cluster resources, for example, namespaces, pods, this stuff. Therefore, a Kubernetes Service Account token is required, as I demonstrated and explained. The Azure Monitor container inside extension or operator, I would call it extension, provides rich monitoring for Kubernetes. When I install this extension on each cluster, I can see the logs of pods, containers, the std out of the containers, nodes, if the node is healthy or not, if something happened on container level or not. Even if I try to deploy container image with a wrong tag, it will be reported in the monitoring via this monitoring container inside. This extension will be installed in a cluster level. You cannot install it in a namespace level. By default, it has been developed like this. And when it can be that you have already provisioned an AKS cluster, and you have enabled the monitoring container inside on your AKS cluster. And after a while, because you have many clusters in different environments, you decide to connect all of them and manage all of them via using Azure Arc. Before installing monitoring via Azure Arc, please pay attention to deactivate the monitoring from your cluster and then install the extension by using Azure Arc. It is important. And for least privileges, if you have a team which must take care about the monitoring, you can give them Log Analytics Reader. If you say no, we have an admin team for all the Kubernetes and they have to have some more privileges, some more permissions. It is based on your scenario. Maybe in a later video, I would talk about privileges, how to manage privileges, identities by using PIM, but right now the focus is connecting Kubernetes cluster, Azure Kubernetes cluster to Azure Arc. And for the Kubernetes clusters behind firewall, the specific endpoints must be enabled for outbound access. Please don't forget it. You can find all the endpoints in Azure documents. I can provide the link in video caption. Okay, jump back to practice. Let me show you where I deployed the monitoring. As I mentioned, I have implemented the whole Arc relevant implementation in a separated TF file to make it for myself easier to explain it for you. And of course, the other reason is when a Terraform file is so long, of course, it makes sense that you think about it, how you can manage the resources in a better way. For example, I have data here, and I have Arc Connection relevant information here. What are data, for example? The data is important in this part of video as well. Data is all the Terraform resources which are started with data. Either it is getting an information from Azure portal directly by using Resource Manager, or I'm using the previously created state file which has the output that are relevant for me in this video or in this implementation, sorry. As you see, I have a module for implementing AKS and then another module for implementing monitoring stuff. It's important to keep them separated. Of course, you can implement all of them in one. I provided the implementation in separate implementation to show you if you have a team responsible for monitoring, then keep the monitoring stuff in another module. If you have a team which is responsible for network, keep the network in another implementation or module. If you have a team which is responsible for enterprise cluster, then keep it separated. Because for each module or for each implementation here, we are saving a state file. Terraform is working based on a state file. And if you lost the state file, one state file, then the whole will be lost. Okay, let's see how I how I installed the monitoring extension on AKS cluster. In the main file, it is the whole implementation of the AKS and node pool of the AKS. In the Arc extension are the relative resources for Arc. First one is Arc Connection. Great, we talked about it. We know that it works. Then I go to Azure Arc extension Monitor, which have been implemented in Bash under Arc extension monitoring folder. I come back here and then we go through the code. I pass some input parameters and then I log in with Service Principal. In this step, I would not need kubeconfig anymore, because kubeconfig is not necessary after connecting with Azure Arc. Then, as I mentioned, the connected AKS, actually in this step, this one is not necessary as well, because we have connected the cluster to the Arc. Now in this step, Kubernetes extension is important. And then I look at it. If it has been installed, then I will update it unless I would add it. Then I go ahead. As you see, I pass the Log Analytics Workspace ID here as input parameter. I take it and create the string path, which is used in the monitoring extension in installation. And then I say here, yes, command line, please install Azure Monitor container, which is the namespace name. As you see here, I can make it a little better that you see. Namespace is, maybe I have to provide the token again. Great, Azure Monitor container, and it is Azure Monitor container is the namespace name. And then the cluster name is this one. Resource group is for Arc connected. It is important here to mention cluster type is connected cluster. If it is only a usual cluster, AKS cluster, without Arc connection, then you can write cluster here. But in this case is connected cluster. You can refer to Microsoft document to find more cluster type. Actually, I have provided the link in my slide. Then I would provide a link to my slide in my video caption. And then extension type is Azure Monitor container, and then the information of Log Analytics workspace ID. Maybe I explain a little more here about extension enterprise monitoring. In enterprise monitoring, I have many configurations which are not relevant for this video, but the important part is Log Analytics workspace provisioning. I have provisioned Log Analytics in this step. And then in the output of this module, I said, yes, please keep the Log Analytics ID as output. It gives me the possibility that when I come back, let me save it, give me the possibility when I use Terraform remote state for example, the name is monitoring. It can be XYZ. I wrote monitoring only to bring more clarity in my code. Then I can refer to the state file where I saved for the enterprise monitoring. As you see, the whole information here is the same as provider here. Backend for remote state. And then, sorry, I closed it. And then I use the information here. If I go back to the Azure Arc, exactly, if you look at here, I see that I'm saying as the last parameter, you should pass data Terraform remote state monitoring, the name of the remote state, and then outputs. It is important to say outputs because the output variables are listed under outputs when we are using remote state. And then I say Log Analytics workspace. It is exactly the name of the variable here. And then I have access to the Log Analytics workspace. In this case, if I have a central monitoring, then I can use one Log Analytics workspace ID for 12 cluster that I have. Of course, it is based on your organization, based on your compliance, based on your decision, based on your solution. But if you want, then you can use it and use one Log Analytics workspace for all your clusters. Okay, let's go back to Azure Portal. Therefore, if you go to Arc and then Kubernetes clusters, then metadata object of the cluster, then you can go here into Insights to see the logs of the cluster, what has happened, what is working, what is not working, in the report, in the nodes, how many nodes do you have, how many consumptions do you have, and then controllers, containers as well. But of course, it is one of the ways or one of the places that you can use to go to the logs. The other one is using Azure Monitor. Then let me do that. Then you can use here containers. You would see, if it comes, you would see the whole connected clusters that you connected them to the Arc here, with a difference that if it is Arc connected, a blue oval is under the logo. If it's directly connected to Azure Monitor, then it is the actual instance. Then you can click on it, and the same as directly in Azure Arc. Then you can go to the logs, you can select a container, and then select one of the containers to see what has happened on this container. I would try to provide a small sample on cluster. I mean to deploy a small application, .NET application on the cluster to show you how deep you can see the logs that are generated on the cluster. But I hope this video could help you, and I hope you enjoyed the video. Thank you for your time and watching my videos.